This is Dan Abbott, and this is not Lecture 8. There is no Lecture 8 for the AEDD260 class. That's the assignment where you have to develop a standards manual contents, table of contents, and you're on your own on that one. Well, you have some references, but as far as the specific assignment goes, I'm expecting you to go and do some research, come up with some references, and then based on those references, develop a table of contents that's thorough and comprehensive for a standards manual. So this is actually for Module 9, and this is our second level instruction on AutoLisp programming. Just a quick start where we were when we ended the last one. We had gone over the setQ function, and we had taken a look at this program for automatically inserting a title block. Just want to point out a few things here just so that kind of remind you. One is that every AutoLisp program is completely enclosed in parentheses, and then internal to that program, the individual elements of the program are also enclosed in parentheses, and that you must have balanced parentheses. So this function up here shows you that you're beginning with an open parenthesis. dfun is in blue because it in fact represents a AutoLisp function. Defined function is what it means, so we're defining a new function. The C colon in this case refers to command, so the function we're defining will act like an AutoCAD command. The name of the command is ITB. The reason that's in black is because it's something that was created by us as programmers, or by me. Sometimes you put things in those parentheses that come after it, and sometimes you don't. We'll talk more about that today. And then every function, Lisp function, has to be preceded by a parenthesis, and except in one sort of unusual case, an open parenthesis must be followed by something that is blue, which means it has to be followed by something that is an AutoLisp function. In this case, the word command is an AutoLisp function, and it refers to AutoCAD commands, and then can call those commands, which have to be quoted because they are strings. That's an important programming distinction between a string and a numerical value. A string is something you can type at the keyboard. Numbers can be strings, but letters cannot be numbers. Numerical value is one thing, how it's represented either on the keyboard or to you in an alert box is another. So if something is presented to you where you can read it, or you're indicating that it's something you would have typed at the AutoCAD command prompt, you have to enclose it in quotes. The period and the underscore come from the textbook that you're using, and when I wrote that textbook, I put a period and underscore in front of all the code because it was published in several other countries. The period simply means that if the command that follows has been undefined, which is possible to do, use the native command anyway. And the underscore means that if the program is being used in a language of AutoCAD other than English, still use insert, the English word insert, as the insert command. So period just means that even if somebody has undefined the command, it can still be used. Underscore means even if they're using it in the Russian language or French or some other language, the word insert will still be seen as the AutoCAD insert command. A couple other things. In this case, C colon does refer to the C drive because it's inserting a title block that is sitting on a drive, in this case the C drive. You normally would not keep anything directly in the root of the C drive, and in fact you cannot normally save things in the root of the C drive because you have an access denied error. In AutoCAD, the AutoLisp programming language delineates folder names and file names by using not a backslash, but either a front slash or a double backslash. That's because a single backslash has been reserved as a control character for some other applications within the program. So in order to bring something in from a folder named blocks, you do the front slash to delineate the word blocks as a folder name from the C drive, and then the front slash to delineate it from the name of the drawing file, in this case tbinch.dwg. A couple other things just a reminder. When you have to indicate something you would otherwise type at the command prompt, again, you put it in quotes. So if I'm being asked where to place this block, that's at 0, 0. It's in quotes. Two quotes with nothing in between. And when I say nothing, I mean not even a space. Acts as though you press the enter key. So whatever the default is, and in this case the default is going to be the XY scale factor, the X scale factor, the Y scale factor, and the rotation angle. The defaults are always 1, 1, and 0, so you can accept defaults by simply putting in double quotes. Not a bad idea to put the actual value in instead of the double quotes, but you don't have to. This was given as an example of a basic program that then gets inflated, or in some cases people might call it bloated, by adding some features to it. So in this case, you're going to insert a title block. In this case, you're inserting a title block that does some things other than just bringing the title block. And it's got the same format, but in this case, there are some things in the quotation marks. Not the quotation marks, the parentheses, sorry. And one of the things you have is a front slash, which is simply a separator, because there are two types of information that can be placed within those parentheses that follow the function that you're defining. So again, we're defining a function. In this case, instead of being called ITB, it's being called InsertTB. Afterward, we could have put something called an argument here, which we don't have, so there's nothing in front of the front slash. After the front slash are things called local variables. And these are things that I came up with when I was writing the program to represent data that would change. So they're basically variables, and they're variable names I came up with because I came up with them. They're in black. L name stands for layer name. L color stands for layer color. SS1 stands for selection set 1. I could have named these things anything I want. Those names made sense to me. That's why I use them. They're in black because I created them. By placing them here, it means that as this program runs and values are placed in those variables, they're bound to those variables, those values at the end of this program will return to nil, N-I-L. It means that they won't hold their value once this program runs. The reason that I normally don't put them in here when I'm developing a program is because then I can go back and check and see what value was located in LName or what was located in LColor or SS1. Once the program runs, you do that so that there's no danger that if you use the same variable name in another program, it won't somehow maintain the value that was bound to that first one and then mess up your other program. This introduced us to some get functions. There are a number of get functions. In this case, get string. Get functions are designed to get data or information or input from the user. So get string says type something. And what it indicates after that is a prompt explaining to somebody what it is they're supposed to type. In this case, the first thing it does is says we're going to set a variable LName equal to whatever this person types. This is a way for whatever I type to get bound to that variable name. So get string means I'm typing it at the keyboard. T is simply there so that if I put a space in, AutoCAD doesn't see it as an enter, it sees a space as a character, as though I had typed the letter A or the letter B. And as a result, it brings it in as part of the name. So it's possible to have spaces in layer names, and since it's possible, I use the letter T so that somebody who was typing in a layer name could do that. The \n, here's a case where the backslash is a control character, and what it means is what follows has to be interpreted as an internal function. What follows is this lowercase n. This is one of the few places where case matters, but the case of this has to be lowercase. N stands for new line, and all this means is that in AutoCAD, when you run the program, at the command prompt, instead of stringing this prompt along at the end of wherever you were, it's going to go down to a new line so that it sits out by itself and it's more noticeable. A couple other things to point out as a reminder. I put a colon here, not because it's required, but because that's how AutoCAD commands work. And I put a space after it, again, not that it's required, but that way there's a space between the prompt and whatever the person types. Since that's the way AutoCAD commands work, my suggestion to you is if you're writing an AutoLisp program, make it work the same way AutoCAD normally does, so if people are using it other than you, they're not surprised by anything. We have the getString function used again down here to get the color, and there's no T because color names cannot have a space. Therefore, we don't want the person typing something in with a space. So by omitting the letter T, it means that if they enter a space, it's going to, well, what's going to happen? It's going to be as though they press the Enter key. Then we have the insert command. It looks just like the one that did up here, and it goes and inserts a block at 0, 0, and then it takes the defaults for X scale factor, Y scale factor, and rotation angle. We have another setQ function. That actually stands for set quote. I think of it as set equal to because it was easier for me to remember what it meant. And what we're saying is we're going to set SS1, again, another variable that I invented, or I came up with, equal to the last entity created. That's what ent last does. You'll notice ent last is blue. When placed in parentheses, it simply selects the last thing that was created. The last thing created here was that block that I just inserted. I save it to a variable name, and I could have put more than one thing in there, but I didn't have more than one thing, and ent last will only select the last item, period. Then I use the layer command to create a new layer based on the information I got up here. The change prop command, CHPROP, to change the properties of SS1. What's SS1? SS1 is equal to the last thing that I entered. When you're asked in AutoCAD to select entities, you have to tell it when you're done selecting by pressing enter. So that's what that double parenthesis is right there. What property we're going to change, the layer that it's on, what layer we're going to put it on, LName, the layer that was defined up here as a destination layer. Enter one more time gets you out of the layer command. So just to kind of review to see where we are right now. So let's go down. And by the way, this is from the book as well. All the code in the book has a table like this. It takes and breaks down each line and tells you what each line means. So there should be no reason why you can't go and try to figure out each one of these things and then be able to use them again. What we're going to do now is move on to pulling data out of the drawing, creating new points, and doing things in AutoLisp that involve actually creating entities. The first thing we're going to do is create a command that will allow you to pick 2 points and place a lumber section symbol in between those 2 points. So we have to start by analyzing what it is we want to do. And once we do that, we can break that down into steps and then write code in AutoLisp that will go through those steps. So if you think of this lumber symbol as having 4 points, and point 1 is the lower left-hand corner, or a corner, it doesn't have to be the lower left. Point 2 is, say, the opposite corner. If I pick those 2 points, I can create a rectangle from that data, because the x-coordinate of point 1 is going to be the same as the x-coordinate of that corner right there, which we're calling point 3. The y-coordinate of point 2 is going to be the same as the y-coordinate of point 3, so we can create point 3 from the x-coordinate of point 1 and the y-coordinate of point 2. Point 4, likewise, we can create from the y-coordinate of point 1 and the x-coordinate of point 2. So all we need is 2 points, and it will then allow us to draw a square. And that as long as we're talking about something that's horizontal or vertical. And this is designed for something like a full section elevation in an architectural drawing. And in that architectural drawing, the section symbols are almost always going to be horizontal or vertical. So in the program we're writing, what we want to do is ask the user to select point 1 and then to select point 2, the opposite corner, and that will then be used to create or determine mathematically points 3 and 4. Once all 4 points are created, they can then be used to draw a rectangle, and then they can be used to draw lines that go corner to corner to make that symbol. So that's what we're trying to do with this program. So the program itself is going to look like this. We'll go ahead and we'll type it in a second. So the problem, this is not a problem anymore. This is from a slide from a workshop I did some time ago. AutoCAD 2008 had a problem with OSNAP coords, but that should not be a problem anymore. I don't think. Let me look into that one. All right, now what we're going to do is define a new function. I call this structural section, is what that stands for. Now those variables, the local variables, we would add those after we make sure the program works. So setCube.1 means we're going to set a variable named pt1, and I just came up with that name, that's why it's black, equal to getPoint is another get function. It's asking the user to select a point, which they can do by either selecting a point on the screen or typing in coordinates. And of course, if they select it on the screen, they can use an object snap as well. Again, when you have a prompt, if you put a \lowercase n, it goes to the next line in the command prompt, and it's asking for the first corner of the rectangle, colon, and space. Asking for point 2, get corner. The reason for that will be obvious when we do it, but if you use get corner instead of get point, and you refer to another point. So pt1 here is the same variable that we defined up here. And what get cornered does is it creates this rubber band rectangle starting at whatever location you identify here and just moving with your cursor, which is the way the rectangle command works in AutoCAD. So it means that when we go to create this rectangle, it'll look just like the AutoCAD rectangle command. And then we say diagonal corners so they understand they're not trying to pick all 4 corners. We only want 2 corners to be picked. Now we're going to create point 3. So now we have a new list function. Well, 2 new list functions. One is list and one is nth. List as a function will create a new list of something. In this case, we want a list consisting of an x and a y. Coordinate for the z is just going to be 0, so we don't actually need to get that. But right now we want a list, and inside that list we want 2 values, an x value, a space, and a y value. So we're going to create that list. And again, the parentheses on the outside of this, that open parentheses on list, is the same as this next to the last one right here. That one at the end closes the beginning of the line. So the beginning of the line has an open parenthesis. It's closed over here. The next open parenthesis is closed right here. And then inside that group of objects, or that group of data, we have some more parentheses. So the one right here is going to group those things together. And what it's saying is go and find the nth. In this case, nth means which number in a group. And so, or in a list. PT1, the point that we picked up here, is a list consisting of x space, y space, z space. The nth 0 item in that is the first item, because computers count by assigning 0 to the first item in a list. Just the way it is. There's a good reason for it, by the way, but just don't get bent out of shape about it. The first item in a list, when you're going down through and numbering them, is 0. So nth 0 means the x coordinate that's contained in PT1, because nth 0 is the first item in the list consisting of PT1. PT1 is a variable that we then bound to the x, the y, and the z coordinates of the point that the person picked. So the nth 0 member of that list is the x coordinate of point 1. The nth 1 item in that list is the y coordinate. And if we wanted the z coordinate, that would be the nth 2 item in the list. So what we're doing is saying take the x coordinate of point 1 and the y coordinate of point 2 and put them together in a new list and assign that to point 3. That makes point 3 then the same x value as point 1 and the same y value as point 2. We do the same thing down here for point 4, but for point 4, what we want is the x value of point 2. That's this one right here. And it's going to be the same because it lines right up with point 4. Then we want the nth 1 y value of point 1. Point 1's y value is going to be the same as the y value of point 3. I just said that wrong. And you can see that I said it wrong down here. We're creating point 4 right now. It has the same x value as point 2. And it has the same y value as point 1. So the code here is correct. I just misstated when I was talking. Then we say let's draw a rectangle. And by the way, the command for rectangle is not rectangle, it's rectang. The command rectangle is not recognized as a command because it isn't. Rectang is the name of the command. I'm saying draw a rectangle from point 1 to point 2. Then draw a line from point 1 to point 2. Then draw a line from point 3 to point 4. It should draw that shape. So what I'm going to do right now is switch over to AutoCAD. And I'm going to switch to AutoLisp, which is right here. And we're going to type in that code. I'm just going to pause briefly while I type so you don't have to hear me type. Actually, I am going to type it while I'm talking because it gives me a chance to explain a few things as well. So we're defining a new function. C: means it's a command. SSECT is the name of the command we're creating. I'm going to leave those empty for now because I'm going to be troubleshooting this, and I want to make sure that whatever value is assigned is held even if I've run the program so I can see if that was a source of an error. Now I come down here, I'm going to do the setQ function. SetQ means set equal to. I said let's do PT1, that's what I called point 1, open parenthesis. It's got to be followed by something blue. In this case, it's going to be the function getPoint. Now, when you have getPoint, you can put in a prompt. \n means put it on a new line. Select the first corner of the rectangle, colon, space, quote, and that's all that I need. Now you notice when I typed in that final quote, it went only to the getPoint quote because that's the one it's closing. I'm going to do one more parenthesis, and I said quote, I meant parenthesis. Do one more parenthesis, it should then reflect up here. So now if I double click here, it should highlight that whole line. If I double click inside here, it should highlight just what's inside those parentheses. Now the easiest way for me to do this next thing is to simply copy it, go down below, paste it, and then change the PT1 to PT2, and now we're going to change getPoint to the function getCorner. And the one thing you do have to remember, you have to change what the diagonal corner of the rectangle. You have to change what the prompt is, and then after the prompt, we're going to have to tell it to go and start at point 1 with that rectangle. I'm going to do one line at a time here. I'm going to double click on that and I'm going to load that line. Look over here, it's asking me to select the first corner. I can type it in or I can just pick a point. I'm just going to pick a point. Down here it shows you the return on the console that I happen to pick 18.580 to 9.68015, and 0 is the Z value. So the first item, nth 0 item, is 18.5. The nth 1 item is 19.68, etc. Now if I come here and I issue that and then load that, you'll notice I've got this little rubber band rectangle. It's anchored at PT1 because I identified PT1 in the code right there. So wherever I put this, it's now going to show me what that point's going to look like as a rectangle. So now I'm done with that. I'm going to come back here. Now what are we going to do? What are we going to do with that? Well, now we're going to create a new point. We're going to now set Q PT3 is the next one that I did. And for that, we're going to say let's make a new list of values. That new list of values will consist first of the x value of PT2. Bring that back up so you can see what I'm doing with that. Bring that over here. Bring that right over there. So now what we're doing here is duplicating PT3. And again, PT3 is going to be a list consisting of the x value of point 1 and the y value of point 2. So in order to do that, I say let's make a list of the nth space 0 item from PT1, close parenthesis. So that gives us the x value of PT1. And let's also then add, and the next item in the list will be the nth 1. And notice NTH is blue, nth 1 of PT2. Close parenthesis, close parenthesis, close parenthesis. So if I then load this and run it, down here it's going to respond with 18.580 and 18.3185. That's the x value of point 1 and the y value of point 2. Tell you what, let's just to keep those things make them easier to keep track of. It's not a bad idea to type in values that you can then remember. So I'm going to start this again. I'm going to come back up here. I'm going to load that. And I'm going to just say I want my first corner to be 1, 1. Then I'm coming down here and I'll do the get corner. I'll come over here. So you see it's starting at 1, 1, and I'll say my next corner, I want that to be 10, 10. Now, it doesn't draw anything. All I'm doing is keeping points. Now you notice down below, the first thing I picked says 1 space 1 space 0, 10 space 10 space 0. So now when we do this, it should say 1 space 10. Now we're going to do the same thing. Again, I'm copying this, but this is really handy because it's quick. But you have to be careful that you don't forget to make the changes necessary here. So now I'm going to say, all right, we want the x value of what? Well, we want the x value, in this case, we're trying to come up with 0.4 now. We want the x value of 0.2. So instead of x value of 0.1, we're going to change that to a 2. Then we want the y value of 0.1. So we're coming over here and we're going to change that to 0.1. This is a common mistake people make when they try to duplicate this. They start copying things and they have the same exact line right here, which means you're not going to draw a rectangle. So now if we load that in, down below it says 10 and 1. Well, that makes sense. That's 1 comma 1. That's 10 comma 1. That's 10 comma 10. 10 comma 10. And that is 1 comma 10. So now 0.4 is 10 comma 1. So now what we're going to do is go and draw something, and that's what the rectangle command comes in. So the first thing we'll do here, come down here, open parenthesis, command. If it doesn't turn blue, something's wrong. The command we want is, you can do point underscore if you want. You don't need to when you're testing this out, but you can. I'm just going to leave it out. I always put my commands in capitals just because it's easier to scan. So again, rectang is the name of the command. And I want to start at 0.1. You notice there's no quotes around these variables. They're variable names. They contain values. Some of them have quotes, some of them are numbers. But the variable itself would not be seen as a variable if you didn't type it as it appears. So it has to look exactly like this one. Sometimes for complex variables, I'll copy and paste them just to make sure that I'm not making a mistake in typing. Let's do that way. So I'm going to double click on that, copy it, bring it down here, make that 0.2. Now that's going to draw my rectangle. And if I want to test that to see, go back over to AutoCAD, I'll load just that part of the line, even though I plan to add something to it later on. But if I do that, you notice I just drew a rectangle here. Now it's a square, but a square is a rectangle. So now that's fine. Now I could, and maybe I'll do that for this just to make it clearer, come down here and go back in the command prompt. So command, line. So now I want to draw a line from PT1 to PT2. And then I want to get out of the line command. And then I want to draw another line from PT3 to PT4. And the way that looks here is right there. To get out of the command, I press enter. Then I go back in the command prompt, and then I go from 0.3 to 0.4. So again, just to break this down, so now we're out of the line command, because don't forget the line command is persistent. You stay in it until you stop picking things. So I'll once again change the format a little just so it's a little clearer what I'm doing. I come down here and now we're back in the line command, and now we're going from 0.3 to 0.4. We're going to stop here, go back over to AutoCAD. So now I'm going to just double click on this and load that line, and when I load that line, it draws that line over to the left. I'm going to double click this and load that line. It does this. So now, am I done? I am not done. And in fact, if I try to load this program right now, or even if I just go here and try to check it, when I do that, it's going to give me an error. It says error, malformed list on input. Why? Something is out of whack. If I double click on this, it says the whole thing's out of whack. If the whole thing's out of whack, guarantee you left out the last parenthesis. If I come to the beginning and double click, nothing happens. If I come here and double click, something happens. Here and double click, something happens. Go to the end and double click. It should highlight the entire program. It doesn't. What did I leave out? The final parenthesis. Double click on that now. Everything looks pretty good. I go and do a check on this. The check is done. Everything looks right. I can load this whole thing, or I can load the entire program like that. Now I come back over here and I use my new command, and it says select first corner of the rectangle. Now I can pick any 2 points I want, and when I'm done, no matter what I do, it's going to give me a section symbol that's a rectangle in those two lines that go across. Now let's do one more thing that might improve this. And one of the things, by the way, if you've got running object snaps, sometimes running object snaps kind of get in the way, except the default setting is for object snaps to be overwritten by a Lisp program. But one thing is, let me just erase all this. So suppose I go ahead and I do one of these, and I go, oh, I didn't mean that, and I got to undo it. If I undo it, it's going to take 3 steps to undo that. So there is a way, when you write a program, to say, let's group this whole thing together. And we'll group this whole thing together so that if I do an undo, it'll just get rid of everything that I just did. Here's how you do that. We'll go back to the beginning. I'll use the command function, type undo, and I'm going to undo begin, which is simply, if I go back over here to AutoCAD, and I type undo, begin is one of the options. I could have typed in B here, but I'm going to do the whole thing, begin. So now that's beginning the undo function. I come down here, do the same thing. Let's put in the parentheses, command. By the way, you notice I misspelled the word command, and I knew it immediately because it was black. Undo once again, and now this will be our undo end. And again, if you look over here in AutoCAD, end is also one of the options. Now watch what happens when we load this time and run it. Come over here and I say I want to run that program. Let's I want to run the program, and I do that. I don't like it. Undo. The whole thing goes away, because what it does is it groups together, for the purpose of undo, everything between the undo begin and the undo end. That's actually a really nice thing to put into a program. If you've ever run that installation program that I wrote, let's just quickly load that. If I run that program, which is right here, if I load that program and run it, and say, I want this to be 6, and no, and then I start picking my points, it actually does quite a few things to put that in there. So now you'll notice if I go to undo this, it all goes away at one time. If it didn't, that would be 30 or 40 steps that I would have to undo. So if we were to open that program, which is right here, you'll notice that there is, right at the beginning, command undo begin, and this is all the things that it does. And you would have to undo every single one of those one at a time if I hadn't started with undo begin, and all the way down at the end, almost at the end, undo end. So everything between undo begin and undo end is considered one thing, which is why when I ran that and went, nope, I didn't mean it, I didn't have to sit there. You can actually see if I come over here and look at the commands. This is all the things that it just did. So, all right, so that's our, let's just close, we'll just minimize that. So that is our section program. Go back over to this and we'll make that full screen. So that is how you can put together individual points from data that you get from the user. Now, stopped here on 216. Oh, so now I want to do something else. Did I cover this in the last one? Oh, that was when I did this for 2 years ago. Anyway, I just threw that in there because when I did a presentation, I stopped there. So now, when I did the first presentation, though, I stopped prior to that. So now what we're doing is looking at some more points. So here now, it's something that I wrote a long time ago, because when I was doing floor plan dimensioning, it was frustrating to me that in order to dimension halfway between the walls, I had to go in and draw a little line in there and then snap to the midpoint. Now that was prior to the introduction of an object snap called M2P, midway between 2 points. That does make it easier. I still think it's a little clunky, and I like the way this program is structured. So here's the problem we're trying to solve. And again, when you're trying to do something like this, you start by kind of listing, what would I have to do to solve this program? I want to be able to run a program that allows me to select this wall, and select this wall and have it place a point that is halfway between the two walls. Later on, when I'm dimensioning, I'm going to dimension to those points using the object snap node. And that's the purpose of this, is to be able to go halfway between two things. So I'm going to go AutoCAD. Okay, so now I've got a floor plan here in AutoCAD. Let's bring up our Lisp program as well. So I've got a floor plan here in AutoCAD. And the problem is when I go to dimension it, I say I want to do a linear dimension. I want to go from here to, well, the midpoint of that window probably is something here, but you notice, there's a couple endpoints. So I'm not sure, absolutely sure that that's the midpoint of that window, but maybe it is. Guess it is. Then I want to go halfway between here and here. And in order to do that, I would have to go Shift right click midway between 2 points. Say go halfway between here and here. And now I would have to do that apparently because I made a mistake. So I'll do another one. Do a linear dimension. I'm going to go from that point right there, point here, put that down like that. So then I do a DCO for continue. I come over here and I'd have to go Shift right click midway between 2 points, pick this and pick this. And I got that. Now what I want to do here is put points in all these locations instead so that I can dimension to those points. So I'll load a version of that Lisp program mid, and it's right here. Now the purpose of this is so that I have a new command. I can call it, say mid, ask me for first point. So for instance, I can go over here and say I want to put a point halfway between those two things. Doesn't really show anything. Then I go back in the mid command, and now I want to put a point here. So I've got it set for nearest so that I can then just pick any point along here and it puts a point in like that. Let me turn the points to a different look so you can see them better. So there it is right there. So I've got a point here and I've got a point over here as well. Just get rid of that. So what I'd like is to have points everywhere so that I can dimension a little more quickly. So in order to do that, I'm going to go back to the mid. I'm going to have another program here called mid that I don't use nearest. I use nearest because I like to be able to bring the points up inside. But let's go to one where it's set to endpoint instead. So I have a mid program called mid end. I'll load that. It's going to create the mid command again, but now what it's looking for is endpoints. So if I come over here, I can pick that endpoint right here, or I can pick the endpoints here and here, and it's going to put those points in there for me. So let's first start with a command called multiple. And multiple allows me to issue a command and just have the command repeat. So now if I have this thing set up, I can say put a point here. I can say, and it does it. I can say put a point here and between here and here, and it does it. Put a point between here and here, does it. Put a point between here and here, does the same thing. And I can do the same thing down here. Place a point here, point here. Now I'm putting these points right on the dimension layer because I know I can turn them off, but I could have a special layer just for the points. So what I'm doing here is establishing a location to which I will be dimensioning later on. And I'll show you why this is such a useful thing as soon as I get done. Okay, that's good enough. Now I'm just going to also put points at the corners because that's going to actually be helpful to me in just a minute. So I'll put these points at the corners. Do another one here. I'll do another one down here. Now I have to say that the way that I did this when I was drawing a lot of floor plans was my window and door symbols were always nested blocks. And I'd make a block out of the window symbol and a block out of the door symbol and then bring them into another block, and I would make a new block out of it that simply had a point at the midpoint. And then when I inserted the windows and doors, I'd explode them. So the actual block of the window was there, but it left this point out where I could get a hold of it. And I'll show you why. Now that those points are there, and we're going to get to the list part of this, I just want to show you why this is useful. I'm going to go, and I'm just going to grab everything right here. Go over to Properties, go up to Q Select, could have typed it in instead and said, from that selection set, just get all of the points. And I got all those points selected. Now I'm going to use the qdim command. In the qdim command, I'm going to come up here and say I want continuous dimensions, and that should do it. I'll come down here. Now bang, I've got, looks like I have maybe in, well, that's what the number is. So, but I get my dimensions in there automatically. So now if I want to do the same thing up here, let me get rid of that nav cube. So if I want to do the same thing up here, I start by making a selection set. Then I go over to properties. I'm going to isolate or filter out of that selection set only the points by going to qselect. Now I've got all the points. Now when I use the qdim command again, bingo, I've got all my dimensions in here. So this is really helpful as a way to quickly dimension floor plans in AutoCAD. So now, how did I actually create that command? What I did first was I asked somebody to select the first point, which in this case was the endpoint of that, the second point, and then I made a calculation. Now I used endpoint on this, but I'm going to show you an example I use nearest because I do like having this come up there. And by the way, if we go to DDP type right now, I can completely turn off all my points so they don't show up anymore. But there is actually a little point there anyway called the definition point. So probably what I would do instead is that. That's why I didn't have to worry about putting those on a different layer. So now I can do all my dimensioning like this going to the middle of the walls. And it's a nice quick way to do it. Now I'm going to open up the program. In Visual Lisp. Oh, I just need to clear out here. When you get that little icon right there, it means that something is happening in AutoCAD at the same time that it's attempting to be happening here. So I'm going to open up and we'll look at the mid program itself. And again, you'll notice, by the way, all these programs and I'm opening up have all this disclaimer information at the beginning, which is what you have to do in yours as well. So now here's my entire program right here. And that program looks almost exactly the same as it does in the PowerPoint, like this. Let's just do this because it's a little bit easier to read. So how am I going to go about doing that? First, just forget about this stuff up here. Those are going to become local variables. So first, I'm going to set a variable equal to OS. Why? I want Osmode turned off for this. Because if Osmode is on, I am going to snap automatically to whatever the current running object snaps are, and that may mean that it gets in the way of this program. So I'm going to turn Osmode off. I'm going to set my aperture to something fairly small. In order to make those two changes, I first have to find out how did the person who is going to run this, how do they currently have their object snap set? Because the one thing you don't want to do in a Lisp program is to make a change in something fundamental and then not change it back so that the person running that program, you in most cases, is now going to be surprised that all your object snaps are turned off. So first I'm going to find out how did they have these set up. This is the equivalent, and I think I used this analogy in the last video. If you were going to house sit for me and you came in and you just didn't like the way my living room was set up, it wouldn't bother me if you want to move the furniture around, but when I come home I'd like it to be put back where it was when I left. So you're going to take a photograph when you start off so you know exactly where I have everything set. Here in this Lisp program we're taking a photograph of the current setting for Osmode, saving it to a variable, and the current setting for Aperture, saving it to a variable. Now those two variables are going to come back into play at the end. When this is all done, we're going to set everything back. Now we're going to change Osmode to 512, which is the nearest object snap. I'm going to change my aperture to 3 because it's small enough so now I don't have to worry about selecting the wrong thing because my pick box is a little too big. And aperture, I'm sorry, that's how close you have to get in order for for an object snap to work. Init 1 simply stops the user from pressing enter here. Enter is not a reasonable response to what follows. So I don't want somebody just pressing enter because nothing's going to happen. There's no default. So if you do that, pressing enter, you'll see what happens if I press enter. So that's what that's for. Now I'm going to set a variable 0.1. This is similar to what I did before in the SS sect, or the structural section symbol. We're going to get a point. first point. Well, I'm now going to be going and picking that first point with the nearest object snap on, so I can just move it anywhere I want along those two parallel lines. Another init we're going to get point 2. Now here we're going to build another point. We're going to do it a little differently. We're going to use a function called polar. I'm not going to take it apart with the nth 0 and nth 1 functions because I can't really use the x and y scale factors, the x and y values for the coordinates here. So instead what I'm going to do is use something called the polar function. Here's how polar works. It says starting at a point, go to a specific angle at a particular distance. Now polar has essentially two arguments. The angle that you're going to go, the starting point that you're starting from, and how far along that you're going to do. So it's exactly like the polar coordinate, where you're saying go from this point, the at symbol, a certain distance at a certain angle, but the syntax is a little different. So polar point 1 says we're going to start back at point 1. What angle we're going to go at? The angle between point 1 and point 2, whatever it is. We don't know what it is. Could be 0, could be 90, could be anything else. But AutoCAD can figure that out in AutoLisp by just looking at the 2 points and determining what the angle is. How far are we going to go? We're going to go halfway between point 1 and point 2. So we're going to divide, which is the Lisp function, the distance between point 1 and point 2 by 2. That's going to go halfway there. So this is the meat of this whole program. So once again, we're going to use point 1 and point 2 to create a new program, a new point, mid, that I'm using MID as the variable for. And we're going to set whatever follows mid, and that follows it is going to be polar function here. And we'll see in a second how that all goes together. So mid now will be at a point between point 1 and point 2 at the same angle as those two things are and half the distance between them. Then we go to the command called point. NON turns off any existing object snaps, which is sort of belt and suspenders since I'm actually turning, setting it to something else up here. Anyway, it turns off any existing object snap and puts a point at the location defined by that variable right there. Then I set Osmode back to what it was set for and Aperture back to what it was set for. So now let's go and see how this works. So here's the program. I'm not going to type this in the video. It's all typed up. Ignore this at the beginning for now. I'm going to come right back to that. That's something called error trapping. So down here, I load that line right there, and OS is now set to whatever the current Osmode setting is. So I'm going to go ahead and load it, and it's currently set to 6183. 6183 is endpoint, midpoint, center, intersection, extension, and apparent intersection, which I've added as one of my favorite object snaps, and so that's why that number is so big. So then we know OS is set for that value, and you can always tell what a variable is set for by going and putting your mouse on it, right-clicking, and adding it to the watch. So I'm going to add it to a watch window, and it's telling me OS is set to 6186. Now that's just to save that value, so that at the end of the program I can set it back to that. Now the other thing I want to know is what's my current setting for Aperture. So we'll do the same thing. We'll load that. It's currently set to 5. We don't need to put that in the watch window, but I will just to show you again. Right-click on any variable, add it to the watch window, and now it'll show you what the current setting for that variable is. Now those are variables that I've created. Now down here we've got a set var, which is an AutoCAD variable. So we're going to set Osmode now to 512, and it returns down here in the console to show you that's what it did. Do the same thing here for Aperture. I'm going to set Aperture to 3. Now when when I do this, all that does is says whatever follows, you cannot press enter. So I'm going to set point 1 equal to the get point, and I'm going to set point 2 equal to a second point get point. And we're going to use one setQ function, which you can do. You cannot do that with setVar functions, but you can do it with a setQ function. So I'm going to do this right here. So now the first thing it does is ask me for a first point. Watch what happens when I press enter. Invalid point, invalid point, invalid point. You can't just press enter. So if I go down here and say, well, let's just pick that point right there. Now it asks for a second point. I pick that point right there. Now what I'm going to do is take P1 and add it to my watch window. And you notice it's got an X, a Y, and a Z value. We don't care what they are. And then down here, there's another X, Y, and Z value. But the main thing is that I also used, and get point, a starting point over here. And the reason I did that is so when you pick the first point, you get that little rubber band that comes up showing you where your second point is going to be connected. So you see what it's doing with that little rubber band? That's similar to the get corner function. But all we had to do here is use get point again, but refer to a starting point as point 1. So it just keeps that line there. So it just you can visually tell what you're doing. That's the only reason for that. Now here's where all this other stuff goes. So the first thing, if we go inside this, and you can see what's inside it means. If you do that, it does the whole thing. Do that, it does that polar function right there. Do that, it does the angle. So let's go back up here and load that one more time. So I'm down here and I want to make a point that goes, say, halfway between. Now I need to go back and start again. I've got Oz mode currently set and AP is currently set, but I need to go back here and reset that and reset this. Okay, now. And then do the init get once again, so I can't do the enter. Now these things all happen automatically if you run the whole program. Right now, what I'm trying to do is establish those 2 points right here. So now I get my first point here. I come down with my little line, I get my next point there. So now if you look at the polar function, angle, the function angle, and then you give it 2 points, it's going to tell me what is the angle between those 2 points that I picked, and it tells me down here what the angle is. The angle is given in radians. Radians are not the same as degrees. We'll talk about that later. But that is the angle between those 2 points. Then over here, it tells me what the distance is between those 2 points. If I load that, it says the distance is 5.63 whatever. So that's just the distance between the 2 points that I picked. That wall has a wall thickness of 4, so I picked it at an angle, so the actual distance between the two is that. Well, what I want is half that distance. So right here, open up that up a little bit. So, not that one. Let me just minimize that and then stretch that over. So here, right in front of where the division function is, if I double click on that and load it, it's going to divide the distance between point 1 and point 2 by 2. In other words, it's going to be half that distance. You can see down here, that number divided by 2 gives you that number. So now, the polar function says start at point 1 and go at an angle of 5, whatever that number of radians is, at a distance of half of that. If I do this, it comes up and it gives me a value, an X and a Y and a Z value at that location. Now I can't use that yet, but what I can do is set all of that equal to, and this variable name is M. In my PowerPoint I called it mid, but it doesn't matter what I call it as long as I use it correctly. So now that I do that, it's going to give me the same values. Now I have a location. So now if you look over here, let's do DDP type back to, so you can see when it comes up. So I'm going to set my point type equal to that. So what I'm going to do is you're looking in that area right there. When I come over here and say let's put a point at that location, that's my point right there, and it's created by that line. Now when I'm all done, I want to set that back to what it was, and I want to set this back to what it was. Otherwise, I'm wandering around with nearest as my object snap, when what I want is that little group that I had before. Now that brings up an issue. What happens if I'm running this program and decide to change my mind inside the program someplace? I get to that point right there and I press escape. What happens? Well, what would happen if I didn't have those 2 lines in here, if all I had was the program written like this, what would happen is this. If I crashed this program by pressing escape and came out of it, we would never get to that line and we'd never get to that line, which means we would never return OS. the Osmode variable or the Aperture variable back to what they had been set for. That is really bad housekeeping. That's a bad way to write a program, which is why all programming languages of any substance have an error trapping function. And the error trapping is what would happen if something went wrong. What happens if somebody presses escape, or if they pick a point that doesn't work, or if the program itself rejects what they just did. Well, what we want to happen in this case is we want the program to go, yeah, let's change those things back to what they were if anything goes wrong. So if somebody presses the escape key, they don't now have an object snap that is not what they normally have. So we'll go back here, and now we have this thing called error trapping. And this is something that confuses people, but it's really pretty straightforward. What I want to do is take those two lines right there, and I want to put them into a function that AutoLisp will call if anything goes wrong, and I want it to do those two things. So whatever I would do here, I'm going to put in this little function right down here. And you notice those two lines right there and those two lines right there are identical. And I've got a function that I gave a name, and I called it etrap_1. That's just the name I gave it. It's my error trapping number 1 in case I have other error trapping functions that I use in my other programs. It really is particular to this particular program. So what I'm saying is if something goes wrong, run that function, which will do this. Now there's a couple other things in here. One of them is that you need to put something in the parentheses when you have an error trapping function, and that something in this case is anything you want. I put the word message because I'm going to use a prompt down here that says resetting system variables if something goes wrong. So I'll show you what happens up here. If I load this, and I've already loaded the error trapping function. I do that. So now if I'm over here and I'm in the mid program and I pick my first point and then press escape, I get this little note, resetting system variables. Well, when I got to that point, I'd already reset object snaps to be set only to nearest. But if I come down here and take a look, it is reset to what I had wanted because of this error trapping function. So this is how it works. Up here at the beginning, I use this thing, which is an internal variable, star error star. And what that means in AutoLisp is that that represents whatever error trapping function is active at any given time. So I'm first going to say take the active error trapping, if there is one, and set it equal to a variable called temp, and then set the active error trapping equal to the one I created, because just in case there's another one running. This isn't absolutely necessary, but it's a really good idea. So this is the line that tends to confuse people the most, and all it means is I can have an error trapping function loaded from one program and leave it loaded the whole time. But when I get here, I want to make sure that that's not the error trapping program that gets invoked if somebody presses escape. So I need to say, all right, if I want to go back to that because I have as a general error trapping program, I need to know what it is. So I'm going to save it the same way I saved OS and AP with the values for Osmode and Aperture. By the way, you notice all the color just went away from this? That happens sometimes with VLisp, and it normally comes back if you do that. I don't know what that's about. So now what it's saying is the current error trapping, which is identified as star error star, is etrap_1, which is this function down here, which I loaded with no C:. In other words, it's not an AutoCAD command, it's an AutoLisp function. So if anything goes wrong, it says, oh, go to error trapping. If it goes to error trapping, what does it do? It returns Osmode to OS, returns setvar to Aperture AP, and resets the current active error trapping to whatever it was set for when I started, and then gives me a little message saying, hey, we're resetting variables. And then to avoid having the word nil show up, which is what happens when you run a program that doesn't return any kind of value, any kind of numerical value, I put print a clear line. So this error trapping function has to be in there in order for this to work. If we load this whole program, it automatically loads both things. So then when we say, let's run the program, go over here and do this, it puts in my point and it returns everything with the error trapping. You need error trapping in any program you write from now on where you change any AutoCAD system variable. If you change a variable, make sure you have error trapping so it'll change back to what it was when you start. And you do that by setting a variable of your own equal to whatever it was currently set to. I only made two changes here, Osmode and Aperture. So I just need to have those two variables saved so that I can return them at the end. So now I'm going to go back to the PowerPoint. So that is a little section on how to create points. And you've got two different ways to do it. You pull X values, Y values, and Z values out of existing points. And use the list function to create a new list of those points that you can assign to a different variable and then go from there. You also have a polar function. So that first one is a little bit like absolute coordinates, where you pull the absolute values out, you put them back together. This one is like the polar coordinate function that you could type at the AutoCAD command prompt. Now, and that is the first half of a workshop that I once did. So now I'm just going to go back to the notion of computations, and we took a look at that in this case when we divided the distance between point 1 and point 2 by 2. We use a dividing function. There are all kinds of mathematical calculation functions built into AutoLisp, as you can imagine. The negative sign and these all come at the beginning. They all come at the beginning. Let's go back here to AutoCAD. So I'm over here in this Lisp program, and I'm going to make a new file. So in this new file, if I want to subtract 3 from 6, and I try typing it like this, it has an open parenthesis, red, nothing blue, which it needs because blue represents an AutoLisp function, an integer, a negative, and an integer. If I try to load that and run it, it's just going to tell me, no, I'm sorry, you can't do that. Nothing happens when you do that. Do it one more time. I'm going to load that, try to run it. What do I get? Nothing. I get setting resystem variables because it's an error message. And I do have an error trap function. The error trap function, by the way, is the one that's live right now. So I'm going to do this. I'm going to create a new drawing file. That's just going to close out all the values that are currently set for any of the functions. Now, yeah, we're good. So this now, I should be able to do this. Yeah, without setting it. So you look down here in the console now, and instead of having the error trapping, which I just turned off, it says bad function. Well, 6 is not a function. What is a function is subtracting. So if I come over here and say subtract from 6, 3, and that's how you'd have to do it. Subtracting. It's hard to see right there, but that is in fact blue. I do that right now, and it's not going to return an error. It's going to return the number 3. Does that right here. So in other words, 6 minus 3 is 3. Look at all the other functions. All of them have to be the first thing after an open parenthesis in order to work. So you can multiply, no surprise. You can add, you can divide. You also have something called 1 plus, which just adds 1 to a number, and 1 minus, which subtracts 1 from a number. And the reason for that is there's something called a counter. We'll take a look at this in another video. And for now, let's just say that it's a convenient way to add 1 or subtract 1. ABS gives you the absolute value of a number. So if you have ABS negative 3, it returns a 3. And there are times when you need an actual integer for something, and you do a calculation that gives you a negative value, but you want that to get turned into the number of times something happened. And if you want to do that, negative isn't going to work for you. Arctangent is a trigonometric function. Cosine is a trigonometric function. This is a nice one, CV units. And this is worth knowing. It allows you to convert from one set of units to another. Now, you wrote a program to do that yourself, but if you type CV unit 25.4 and then in quotes put the units of millimeters and the units of inches, it'll convert this value from that to this. So So it'll return a 1. And it has a ton of different units that it does that for. You can look that up to see what else it does. Other calculation functions, you can have an exponent. Raises the root to a power. So if you say exponent 10(3), it's 10 cubed, or 1,000. Fix turns a real number into an integer. In this particular case, it simply drops anything that is not a whole number. There's a reason for that as well, and there's some times when that's helpful. It's a little hard to explain without giving you a specific example, but I have used this before in some of the calculations that I've done. So it's a situation where you need a whole number, and you don't get a whole number, so it makes a whole number for you, but it doesn't round it. It just drops off the second piece, but you then can sometimes get and use for something else. Float converts an integer into a real number. So an integer is the number 3. Float turns into 3.0. And the reason for that is real numbers have to be used if you want a real number to get returned. So if I'm in AutoLisp here, so if I say let's divide 5 by 2, and I do that, and I load it, it's not going to give me 2.5. It's going to give me 2. Because I gave it an integer and an integer. If I made that a 0.0, now it's going to actually give me the value. It's going to give me 2.5. Well, there are times when you don't know what that number is going to be, so you can't type it in yourself, but you can say, let's float 2. So now, if I say float 2 and double click it and load that, it's going to return 2.0. So if I have a variable, and that variable I know is going to be an integer, but I don't know what the integer is going to be, the way to turn it into a number so we can use it as a real number is to float it. So now, if we do that, we're dividing 5 by the real number, 2.0, and it's going to give us the correct result. I'm going to go through the other ones, and then I'm going to stop this video for now, and then I'll make the next one after that. If you have a list of some kind and you say MIN in a list, it's going to return the smallest number in that list. Max returns the largest number in that list. Again, that might not be obvious to you when you would use that, but there are definitely times when you do. Pi is a variable that you can redefine. Don't ever do it. Do never redefine pi as anything other than what it's internally defined as right now. And if you look to see what is it internally defined as right now, you notice it's blue. Okay, it's a bad function. Maybe it's not. No, it is blue. It's a bad function, but it does return 3.14159. Now, if we said something like real to string, pi is the value that we want to do, and we say make it a decimal, and let's go out to 15 decimal places. And we do that. Now, we're going to find out that pi is 3.1415926535897993. That's as good as you can get in AutoCAD. But the idea here is it is possible to redefine pi. In other words, we could be a really bad idea. I could do a set q pi equal to 3. Now, it's going to return 3. Yeah, it's a protected symbol. It doesn't want you to do it. You have to force it to do it. That's a good thing. So we don't want that redefined ever. Now, this is only redefined for the current session, so I'm not too worried about it. Our remainder is after you divide two numbers. If you divide 10 by 3, for instance, it's going to return, I guess I told you, but it's not there. It's going to return 10 divided by 3 is going to be 9.333333. So it would return 0.3333. And there's reasons what you want to do that on occasion. Sine gives you another trig function, the sine of 45. That's the square root. So if you want the square root of a number, you can find that. I think we have... Oh, that's it. Okay. So, and if you know certain tangent functions, you can always calculate the ones that they don't have specific terms for. All right. And then we did this one already, so we went through this last time. I went through it. Okay, this is where I'm going to end as far as calculations go. Yeah, this is where I'm going to end as far as calculations go. There are times when you're running Lisp programs when you're confused because you put in what you think of as an angle, and you're thinking in degrees, and then AutoLisp does a calculation, and it sees what you put in as not degrees, but radians. There's a very big difference between degrees and radians. Computers use radians because it's a much more efficient way to calculate than it is to use degrees. We don't think in radians. At least I don't think in radians. So I want you to know what a radian is, and the fact that because of that, it's important to have a couple of functions available to you that convert between radians and degrees and between degrees and radians. And in the book, I have a description of where that might happen. And I show you an example of a program that would rotate something a certain angle. But if you type it in degrees, it doesn't rotate it correctly enough. And so in the book, in that chapter 8, there's a section on RTD and DTR. And every general AutoCAD or ACAD doc LSP file that anybody uses should always have those two functions in it. Let me just explain what the difference is between a radian and a degree so you can see what's going on. A radian is the included arc if it has an arc length of 1. So if you take a look at that arc right there, the radius of that arc is 1. The length of that arc, the length along the arc is also 1. So in a situation where the radius and the length of the arc are identical, the angle between them is considered 1 radian. Now that is approximately 57.296 degrees, approximately. But if you look at the numbers over here, 0 degrees and 0 radians are the same. 90 degrees is pi divided by 2. Pi divided by 2 gives you an angle of 90 degrees. That's the number of radians that get converted into 90 degrees. So if you take a look at this, if I were to take my I'll take my calculator. So I'm going to take the calculator. I'm going to say let's take pi and let's divide pi by 2. And I get that value right there. 1.5 and then a whole bunch of numbers after it. Now I showed you over here that when we have 1 radian, it's about 57.29. So now we have 1.57 radians for 90 degrees. In other words, pi divided by 2 is 1.57 radians. If I now multiply that times 57.296, I get 90 degrees. Now, why isn't it exactly 90? Because that's a rounded value. In other words, I rounded that to 3 decimal places. If I'd gone out further, there'd be more zeros here, but it would still look like that. But internally, when you divide pi by 2, you get exactly 90 degrees, or pi divided by 2 radians. So 180 degrees is pi, 270 is 3 times pi divided by 2, and 360 is 2 pi. Just the way it is. You just have to know that the computer might do that. And where that normally comes up is you put something in and you try to rotate something at some value that you think is pretty big, like 40. You type in a 40 and it just goes whizzing around until it finally gets to that value in terms of radians. And a lot of times what you think is going to move 40 degrees, just moves a little bit. Because in radians, by the time it gets done using up the 360, 360, 360, i.e. 2 pi, 2 pi, 2 pi, 2 pi. By the time it ends up using that up, whatever's left over is the number of radians it's tilting to. So RTD and DTR are the 2 functions that most programs have in them, and the example I gave you in the book is this thing that rotates and copies. And the rotate copy command I created at a time when there wasn't a rotate copy command. There is now. But at any rate, in order to use it, I had to do a conversion, and the conversion was used right here. So this function is similar to the error trapping function in that it doesn't have a C colon in front of it because it's not an AutoCAD command, but it'll turn radians into degrees. The argument is R. Now you put the R in here. So what happens? You're going to multiply 180 times whatever number you type in radians divided by pi. You do that and you'll get degrees. If you start with degrees, you're going to do something a little different. The same values, but they're not going to be multiplied and divided in the same way. In order to go from degrees to radians, you have to multiply pi times the result of dividing the number in degrees by 180. So if you divide the number in degrees by 180, and then you multiply that times pi, that gives you radians. Well, that makes sense, since 180 degrees is 1 radian. Makes sense? Yeah. Okay, that's it for this particular video. It's been an hour and 15 minutes. I think that's long enough for one video. And what I'll do is then I'm going to make another one as we go moving through the rest of the semester.